Hello students, so in the previous video we had discussed about what is electric dipole, what is dipole moment, what is the direction of electric dipole moment, right? Okay, in that video we had seen an important point that even if the net charge on the dipole is 0, the net electric field was not equals to 0, right? So in today's video we will discuss about the electric field because of a dipole along the axis along the equator. Okay, so first we will discuss electric field because of dipole along the axis, or many of the books are writing it as end on position. It means the same. Okay, suppose let this axis be z axis, this be y axis. Let us say we are placing a dipole. Dipole means system of two equal and opposite charges. Let this be the center of the dipole. Now this will be the total distance 2a. Okay? Dipole plus minus separated by distance of 2a. This is the center of the dipole. Suppose I want to calculate the electric field at this point P. This point P lying along the axis. This is known as axis of the dipole. This will be the equator of the dipole. So first we will find electric field along the axis because of this dipole, and then we will find electric field along the equator. Okay. Now this distance will be of course z, because the point itself is lying along z axis. This distance will be a, because total is 2a, this is a, this is a. Clear? Okay. So this distance will be z minus a. This distance will be z minus a. Now electric field because of positive charge at point P will be away in this direction. So this will be the electric field because of positive charge. Now negative charge will produce the electric field in this direction. Clear? And the distance of the point from this negative charge will be, this is z, this is a, this is z, this is a. So the total distance will be z plus a. You getting the point? This is z, this is a, this will be z minus a. This is also a, this is z, so total will be z plus a. Clear? Okay. And the direction of this electric field will be towards itself. But this point is, this charge, negative charge is far from the point P as compared to positive charge. So magnitude wise, this electric field will be strong. So net electric field will be along upward direction. Clear? Clear? See, this is how I am showing. This is the point. One charge is here, other charge is here. Because of this charge, electric field at this point will be in upward direction, positive, because of positive charge, right? Because of this negative charge, electric field will be in downward direction. But since this charge is at a greater distance, so the value of electric field will be less. So one electric field is in upward direction, another is in downward direction, but this is of greater magnitude. So net electric field will be upwards. Net electric field will be upwards. Clear? Okay. So finally, because of dipole, along the axis, net electric field is in this direction. Okay. Minus q plus q, dipole moment is from minus to plus. So dipole moment will be in upward direction. Net electric field in this case is also in upward direction. So from this you can have one MCQ, one question. What is the angle between net electric field and dipole moment for a dipole lying along the axis? What will be the angle between net electric field and dipole moment for a dipole lying along the axis. You can see the direction of net electric field and dipole moment. It is parallel. So the angle between them will be 0 degree. Angle between them will be 0 degree. Clear? Okay, now let us calculate the electric field at point P. Fine. Electric field at point P. Electric field due to positive charge, electric field because of negative charge. Clear? So positive charge is at a distance of z minus a. I am rubbing the other distance so that you will not be confused. Clear? Positive charge is at a distance of z minus a and negative charge is at a distance of z plus a. The charges are point charges. So we know that the electric field for a point charge is kq by r square. So this will be kq by z minus a the whole square, right, minus kq by z plus a the whole square. Clear? Into p caret. P caret is a unit vector to represent the direction of net electric field. Clear? Since we are discussing about the dipole, we will write it as unit vector, will represent unit vector by p caret. Clear? So this is to represent the direction of net electric field. Okay, solve this. 1 upon z minus a the whole square, 1 upon z plus a the whole square, p caret. So this will be kq. This will go here, a plus b the whole square minus a minus b the whole square. So only the middle term will be remaining, other terms will be cancelled off. So it will be 2za plus 2za, 4za upon a minus b the whole square, a plus b the whole square. So that will be a square minus b square the whole square. Clear? Clear? Now, if I want to write the electric field in the form of dipole moment, so we very well know that dipole moment is charge into distance. Charge into distance. Let us write electric field in form of dipole moment. So 4 can be written as 2 into 2. I can write it as 2kz q into 2a upon z square minus a square the whole square p caret. Clear? I have written 4 as 2 into 2. Okay. What is q into 2a? P. So net electric field will be 2kpz upon z square minus a square the whole square p caret. This is what is electric field because of a dipole along the axis. 2kpz upon z square minus a square the whole square. Now, if the point is very far from the origin, then that means if the point is say somewhere here, then z will be quite greater than a. Z will be quite greater than a. That is if your dipole is short dipole or if z is greater than a, right? Then you can neglect you can neglect a. So neglecting a, we will have electric field as 2kpz upon, this will be neglected, so z raised to 4 p caret. Clear? So this will be q, so electric field will be 2kp by z cube. Use this formula when in the question it is given that the point is very far or your dipole is a short dipole, or consider the distance to be very large. If something like this is given, this kind of condition is given, only then you can use this formula 2kp by z cube. Clear? So one thing is to be noted that for a dipole at far away distance, electric field varies as 1 by r cube and not as 1 by r square. Clear? This was a MCQ asked in your board exam previous year 2020. Electric field was inversely proportional to cube of the distance. In point charge, for a point charge we had seen that electric field changes as per 1 by r square, not as 1 by r cube. But for a dipole at very far away distance, electric field changes as 1 by r cube. Clear? So this was electric field of a dipole along the axis. Now we will see what is electric field because of dipole along the equator. Clear? So now let us find electric field because of dipole along the equator. Equator is also known as broadside position. Okay. See. Dipole is placed here, center of the dipole, origin, no problem. Now suppose we are calculating electric field because of the dipole at a point which is lying at a perpendicular distance y from the dipole. Clear? So that means that will be the equator of the dipole. If this is the dipole, then this is x, this will be the axis, this will be the equator. If you are placing your dipole this way, then this will be the axis, this will be the equator. Okay, fine. This distance is a, this is also a, right? Dipole moment will be in this direction. Fine, we want to calculate the electric field at a point P which is lying at a perpendicular distance y from the dipole. So for positive charge, electric field will be away. Electric field will be away. For negative charge, it will be towards itself. Clear? Fine. So this is the electric field because of positive charge. This is the electric field because of negative charge. Right? This is y, this is a. So this distance will be, according to Pythagoras theorem, it will be y square plus a square. Y square plus a square. Clear? Let us say this angle is theta. So then, if this is theta, this will be theta, corresponding angle. This way. If this is theta, this will be theta, corresponding angle. Clear? This is your electric field. This is angle theta. This will be cos theta. This will be sin theta. Clear? That means this will be cos component of electric field, sin component of electric field because of positive charge. Right? Similarly here, this will be theta, this is E, this will be cos theta, this will be sin theta. Sin theta component will be cancelled out because they are in opposite direction and they are having the same value. See, both the charges are at a distance y square plus a square, the under root of y square plus a square. See, this is a, this is y, so this will be under root of y square plus a square. In the same manner, this is a, this is y, so this will be under root of y square plus a square. So their magnitudes of charges are equal, distances are equal, so their sin component will be cancelled out. So only the cos component will be remaining. Clear? So net electric field will be in downward direction. Net electric field will be in downward direction, this way. See, I am explaining this way. This is what is. I'll draw the magnified image. This is electric field because of positive charge. This is electric field because of negative charge. This was the cos component of electric field. Sin component gets cancelled out. Dipole moment is in this direction. Right? So the angle between dipole moment and net electric field. Net electric field because of the dipole lying along the equator is in this direction. Dipole moment is in this direction. Net electric field is in this direction. Dipole moment is in this direction. So what is the angle now? 180 degree. Previously along the axis, it was 0 degree. Along the equator it is 180. Clear? Okay. Now Now we want to calculate the electric field at a distance y here at point P. So net electric field will be electric field because of plus charge and its cos component, because only cos component is being added up, sin component gets cancelled, plus electric field because of minus charge cos component into unit vector, but it should be now minus p caret because the direction of net electric field and dipole moment are anti-parallel, opposite. Clear? Okay, fine. So this will be electric field because of positive charge plus q, kq by r square. R means this distance, which is under root of y square plus a square. R square will be y square plus a square. This is r for positive charge. Charge is here, point is this is the distance which is under root of y square plus a square. So we will write it as kq by y square plus a square, because the formula is kq by r square. So if I am placing a square here, root will go, plus kq by, because of this negative charge, y square plus a square. Cos theta has been taken common, p caret, and a negative sign here. Okay. So from this triangle, what is cos theta? What is cos theta? Adjacent by hypotenuse. Definition of cos theta: this will be the adjacent side, this will be the hypotenuse. So it will be here, cos theta will be written as a upon y square plus a square raised to 1 by 2 p caret. Solve this. Minus 2kq y square plus a square into a upon y square plus a square raised to 1/2 p caret. So this is 1, this is 1 by 2, 3 by 2. So finally electric field, net electric field for a dipole along the equator. But what is q into 2a? P. So this will be minus kp upon y square plus a square raised to 3 by 2 p caret. Done? Clear? This is the electric field of a dipole for a point lying along the equator or broadside. Once again, what if y is greater than a? That means the point P, if I am putting the point over here, so then this will be y, this will be a. With respect to y, a can be neglected. So the net electric field will be minus kp upon a is to be neglected, y square raised to 3 by 2, y square raised to 3 by 2, 2 gets cancelled, yq. So in both the cases, the only common thing which is that net electric field at far away distance varies as 1 by r cube and not as 1 by r square. For a dipole along the axis, we were having the formula 2 kp upon z cube. In that case also electric field was also changing as 1 by r cube, and in this case also electric field is changing as 1 by r cube at far away distance. Clear? So this was all about the electric field because of dipole along the axis and along the equator. So now in the next video we will solve the questions based on dipole placed on axis and equator.